Hey guys, welcome to another video. My name is Captain Sanjit, and in this video we'll be learning how lift is created. Now before we get into lift and all those amazing things, I would like you to go and have a look at the continuity equation of continuity, as well as the Bernoulli's theorem, which I have posted before, because all this is linked together in this video. So if you haven't had the time to look at it, have a look at it, right? So last time we also spoke about streamlined flow. I hope you remember what that is. So this is an example of a streamlined flow, right? It is all in a perfect streamline. It's like a stream with perfect all the molecules moving behind each other in perfect sync. So this is an example of a nice streamlined flow. This is an aerofoil. We have spoken about an aerofoil as well. Now the first thing that I would like to bring to your notice is this small black point that I have marked, right? So what is that? That is basically called as the stagnation point, right? So as air comes towards the aerofoil, as the aircraft moves ahead and as the air comes, and what happens is basically the air gets split into two different parts, right? One goes above the aerofoil, one goes below the aerofoil, and at this point what happens is that the air is basically coming here and coming to a complete halt. They say that it's coming to a point of zero velocity. The air is stagnant, right? And in this particular point, what happens is that the static pressure is maximum, and the static pressure is so high that the pressure at this point that the air creates, the static pressure is higher than the surrounding atmospheric pressure. And because of this, it also helps in dividing the air in two halves like this. You can't say it is in two halves, but in two parts like this. Air splits and goes above and below around the aerofoil. Now what is the benefit? Why are we talking about this? Because if the air never split like this and went above and below, right, lift would never be created. Now lift, I should first I would like to bring out a certain two words that regularly come in the DGC exams. These are two key words that are related to lift. It is called pressure differential, right? So lift is nothing but a result of a pressure differential. Okay, so air comes in, right? It is split into two parts. Now what happens is that the air moving upwards is forced to flow faster, right? So this air is flowing faster, and this air is forced to flow slower. This is because of the design of the aerofoil. This is the inherent property of an aerofoil, which forces the air above to move faster and the air below the aerofoil to move slower. Now as air moves faster, we remember law of conservation of energy, in which we know that the pressure is divided into two parts, right? One is dynamic pressure and one is static pressure. And in both cases, what happens is, as per the law of conservation of energy, energy can neither be created nor be destroyed, but can only be altered from one form to the other, right? But in this particular case, now there is a total of static and dynamic pressure, and what happens is, as air moves faster, the dynamic pressure increases but the static pressure decreases, right? And as air moves slower over here, the dynamic pressure decreases and the static pressure increases. Now as the static pressure increases, I want to show that there is an upward push. So there's an upward push. So there is high pressure over here formed below because the air is slowed down, and there is low pressure over here, right? and because of this pressure differential, this aircraft or this aerofoil is forced to move upwards, which is also called as lift, right? It is as simple as that. So a pressure differential is created, and so I would like to review again. Air coming towards the aerofoil is split, and there is stagnation point where static pressure is maximum. Now the air flowing above the aerofoil is forced to move faster as compared to the air below the aerofoil. Okay, so faster air means high dynamic pressure, low static pressure, and below slower air means high static pressure and low dynamic pressure. Now high static pressure means the air will push, right? So as the air is pushing upwards and from below of the aerofoil, which is creating lift. Okay, so lift is as simple as that. It is a pressure differential, pressure difference between the lower part of the aerofoil and the upper part of the aerofoil, and that is how lift is created. So that's it guys, happy landings, cheers.